Unifying the principles of quantum mechanics and general relativity has long been considered one of the greatest challenges in physics. Imagine trying to merge the unpredictability of a coin toss with the precise mechanics of clockwork. This is the scale of the problem physicists face when reconciling these two frameworks. These two frameworks, while immensely powerful, describe the universe in fundamentally different ways. This proposal offers an integrated unified framework, merging the deterministic insights of the Alena Tensor with the dynamic emergent properties of the Lattice Framework. The Alena Tensor reimagines gravity, not as a force, but as an immediate geometric response of spacetime to interacting fields. This deterministic framework shows that the curvature of spacetime is directly shaped by these fields, introducing additional terms such as countergravity effects that redefine our understanding of gravitational phenomena. Importantly, field invariance here does not represent a constant value. Instead, it reflects the dynamic adjustment of spacetime curvature to the local conditions of interacting fields. The Lattice Framework brings a complementary perspective. It views spacetime as a dynamic evolving structure, where time plays a central role. Here, time is treated as a parameter, an operator, and a bridge, enabling quantum fluctuations to stabilize into observable structures over Planck-scale intervals. Coherence nodes within the lattice act as points where quantum probabilities transition into deterministic spacetime geometry. When we integrate these two frameworks, we achieve a unified understanding of gravity and spacetime. The Alena Tensor describes the immediate field-driven curvature of spacetime, while the Lattice Framework shows how these effects evolve and stabilize over time. This synthesis reveals a universe that is both instantly responsive and dynamically emergent. An essential consideration in this unified framework is the nature of energy itself. Could energy be viewed as a wave, where time represents a phase of its dynamic behavior? This perspective aligns with the broader framework by suggesting that time acts as an inherent component of energy's oscillatory dynamics, embedding the progression of events within the wave's phase transitions and linking them to spacetime curvature. In this perspective, energy waves propagate within spacetime, and their oscillatory phases correspond to the unfolding of time. This aligns with the Lattice Framework's interpretation of time as quantist intervals, suggesting that the interaction between energy waves and spacetime curvature shapes the observable dynamics of the universe. Field invariance is redefined in this framework. This redefinition impacts the understanding of additional curvature terms by highlighting how these terms emerge as adaptable responses to the interaction of fields with spacetime. For example, countergravity fields introduce novel curvature effects that reshape spacetime geometry, offering practical insights into phenomena such as dark energy and the stabilization of large-scale structures. In the Alena Tensor, invariance adapts directly to local spacetime conditions, introducing additional curvature terms, such as those for countergravity fields. This dynamic invariance does not imply a fixed value, but rather an adaptable geometric response to field interactions. The Lattice Framework complements this by demonstrating how these immediate effects stabilize into large-scale geometric structures through time-dependent processes. Together, they present a comprehensive view of spacetime as shaped by both immediate and cumulative interactions. This integration also sheds light on dark energy and dark matter. From the Alena Tensor perspective, these phenomena are geometric effects resulting from additional curvature terms introduced by field interactions. The Lattice Framework ties these effects to emergent properties of spacetime, stabilized through coherence nodes. Unified, these insights offer a new understanding of dark energy and dark matter as manifestations of the interplay between immediate and stabilized spacetime dynamics. Time is central to this unified framework. In the Alena Tensor, time is implicit, guiding the immediate geometric responses of spacetime to fields. In the Lattice Framework, time becomes explicit, quantized into Planck scale intervals that enable quantum probabilities to stabilize into classical structures. This dual role of time highlights its fundamental importance in linking quantum mechanics and relativity. A deterministic framework like the Alena Tensor does not imply that individual humanity is strictly deterministically designed. Instead, it shows that agency operates within a form of deterministic calibration. Probability informs actionable potential, meaning that while the universe's rules may guide certain outcomes, individual choices emerge through adaptive engagement within these parameters. Think of it as sailing a boat on the ocean. The currents and winds, the rules of the universe, influence your path, but your ability to adjust the sails and steer determines your specific trajectory. This balance between deterministic forces and adaptive agency defines the calibration of probability and action. Philosophically, this proposal bridges two views of the universe: the deterministic field-driven geometry of the Alena Tensor and the dynamic emergent interconnectedness of the Lattice Framework. For example, Einstein's general relativity introduced the idea of spacetime curvature as a deterministic phenomenon, while quantum mechanics revealed the probabilistic behaviors of particles. This proposal integrates these historically contrasting views, suggesting that spacetime is both a structured response to fields and an evolving system shaped by probabilistic interactions. Spacetime emerges as both a responsive and evolving system, unifying the immediacy of field interactions with the cumulative effects of time-dependent stabilization. This proposal is not just about unification, it's a new way of seeing the cosmos. By redefining gravity, time, and space-time geometry, it provides a framework for understanding phenomena like dark energy and dark matter, and bridges the divide between quantum mechanics and relativity. Through this synthesis, we take a significant step forward in comprehending the profound structure of the universe. By integrating immediate geometric responses with emergent dynamics, this framework offers insights into phenomena such as dark energy, dark matter, and the stabilization of large-scale structures, while providing a coherent bridge between quantum mechanics and relativity. The interconnected nature of reality becomes clearer, inviting us to deepen our exploration and refine our understanding of existence itself. This is a proposal grounded in the interplay of ideas and evidence, offering a framework that unites the immediate and the emergent. By exploring these connections, we gain not just answers but new questions, driving us further into the intricate and awe-inspiring fabric of the cosmos.